Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. How can we write a rule for an arithmetic sequence? Well, first of all, we have to know what the rule for the nth term is. And then once we know that, we can use that rule to help us write the rule for any sequence that we see. And in this case, we're going to deal with arithmetic sequences. So the nth term of an arithmetic sequence with first term a sub 1. I say the word sub there, it's just an abbreviation of subscript. Subscript is just the number at the bottom of the variable. And common difference d is given by a sub n is equal to a sub 1 plus n minus 1 times the common difference. So this formula here in white is the formula that we're going to use on these three examples to figure out what our nth term equation would be. Now, when we say the nth term, that would be just our generic equation for the sequence so that we could find whatever term, nth term, of the sequence that we want. So if we look at sequence number 1, it's 7, 10, 13, 16. If somebody asked you, hey, I want to know what the 500th term of that sequence is, and you don't know how to write the rule, you're going to be saying, wow, I'm going to have to write out 500 numbers here to figure out what it's going to be, right? So we have this equation to help us save some time and be able to find numbers in the sequence. All right, so number 1, like we said, is 7, 10, 13, 16. So technically, we would want to make sure it is arithmetic first. Now, this video is all about how to write a rule for an arithmetic sequence, so I'm going to go ahead and give it away. All three of these are going to be arithmetic sequences. However, we could check it. We could say, okay, we are adding 3, and adding 3. So we verified it is an arithmetic sequence, and now we can write our rule. So we're going to start off with a sub n equals a sub 1 plus n minus 1 times the common difference. So a sub n is going to be in our final equation, so we're going to leave that there. Now our first term would be a sub 1. That's what that stands for, first term. So we're going to plug 7 in right here, plus n minus 1. And now our common difference is what we were adding to get to each term. So this would be a 3. Now we can just distribute this 3. So this would be plus 3n minus 3. And now we have a couple like terms here we can combine. So our final equation would be a sub n equals 3n plus 4. Okay, now one thing I want you to notice about an arithmetic sequence, our final equation, it looks very similar to slope-intercept form, right? Y equals mx plus b. Because an arithmetic sequence behaves very similarly to a linear function, especially if we graphed it, it would be a straight line. It would just be points because it would be discrete. We wouldn't draw a line through our points since it's a sequence, but it would appear to be a linear function. So one thing I want you to think of, 3 right here, our common difference is much like our slope. It's how we're getting to the next term. And think about what 4 would be, right? Notice up here in our sequence, we didn't have 4, right? It wasn't part of our sequence because our sequences start at an x value of 1, right? Well, this 4 right here, if we're thinking slope-intercept form, that would be like the y-intercept, right? So that would be like the point 0, 4. All right, so that would be like the 0th term of the sequence. So that's another way to think about it, because if I look at my sequence 7, 10, 13, 16, if I were to extend the sequence back before 7, what would be the number before 7? Well, if I'm adding 3 to extend it, to increase my sequence, then does it make sense that we would subtract 3 to decrease our sequence? Yes, it would, right? So what number would be before 7? It would be 4, right? And so that's where that 4 comes from. So you can use that to kind of help check your work to make sure you're getting the right equation. All right, number 2, 15, 8, 1, negative 6. So it looks like we're subtracting 7 here. And so now we can write a sub n equals a sub 1 plus n minus 1 times the common difference. Notice how I'm writing the general formula each time. That's a good way to memorize the formula, right? You might look at that and go, oh, there's no way I'm going to be able to remember that. Well, if you'll write it down every time you solve a problem, or at least for the first 7 to 10 times, then you'll remember it because you've been writing it down a whole lot. So now we have a sub n equals, this would be 15 plus n minus 1, and then we're going to put a negative 7 right here. So a sub n equals 15. Now let's distribute this. This would be minus 7n plus 7. And combine our 15 and our 7 to get a final rule of a sub n equals negative 7n plus 22. All right, in our last one, number 3, negative 2, negative 5 over 4, negative 1/2, and 1/4. So what are we doing to get to the next term? Well, this would be, if we think negative 2, right, this would be like negative 8 over 4, negative 5 over 4, negative 2 over 4, and then we're going to 1 over 4, right? So it looks like we are adding 3/4 each time we go, right? So plus 3/4, plus 3/4, and plus 3/4. So now we can write a sub n equals a sub 1 plus n minus 1 times our common difference. And now let's plug in the terms we know. So a sub n equals, our first term is negative 2 plus n minus 1. And we said our common difference this time is 3/4. So now we have a sub n equals negative 2. Distribute our 3/4, so plus 3/4 n minus 3/4. Combine our like terms. So we have a sub n equals 3/4 n. And now we could say, we know negative 2 we set up here was like negative 8 over 4. So negative 8 over 4 minus 3 over 4. Negative 8 minus 3. So this would be minus 11 over 4. And that would be our rule right there. Okay, and so that's how you can write a rule for an arithmetic sequence.